Good morning, January 20th, 2025. Fateful day. Quite cold today. I think the cold wave is moving in, so careful when you get out. Dress warm today. All right, so, well, you just noticed that I placed the announcement about this lecture in the announcements section. And I'm just going to do it right there. In the beginning, I would put the announcements on and send email to everyone. But by now, everyone should be able to navigate comfortably within our setting. So I'm just going to put that right in the announcements here, and I'm not going to send emails. All right. Now, let's see here. All right, so this is our class portal. Now, notice, I'm just reminding that here is our YouTube playlist, and first lab that we're going to do, hands-on lab, with actually the bread and butter of things. The instructional preparation video is placed on this YouTube list, so please visit this list often. I'm going to click on it now, and I'm going to show you how I'm organizing this YouTube playlist. So in the beginning, at the top here, you're going to see the sequence of the lectures. So this today's lecture is just going to be underneath this one here. After that, there's going to be everything that has to do with the labs. And underneath everything, there's going to be some additional information. Maybe I'm going to find some sort of interesting news about some game changer, that maybe some new technology came out that I think that's significant. Then I'm going to place that there. All right. So this YouTube list is going to keep populating. So now here's the lab that we're going to do this week. It's called the PA system, and it's a lab. So just click on that, watch it. It's 35 minutes, but you need to have that information there. For this particular lab, there is no PDF paper form. It's this here. That's the preparation for you to watch. And of course, as far as tools, for the most part, please bring at least the regular size. It's called power grip rather than precision grip side cutters. Or wire cutters. Sometimes it's known as wire cutters. Sometimes it's listed as wire cutter, or side cutters, or side cutter. Do the regular size. It's called power grip. The stuff that you use, the tool that you use, that little red one for those little wires that you use with the breadboards. That on one side there's a cutter, there are cutters, and there are blades for cutting, and the other side there's like a wire stripping mechanism. That is not good for our labs. We need the regular size side cutters for that. That's the minimum that we need to have during our labs. All the other tools, such as specific crimpers or specific data cable strippers or coaxial strippers, that will be provided for you in class. We have those. I'm not going to ask you to purchase all the punch down tools, all at once. If you decide to go into this business, then of course you're going to start arming yourself with the proper tools. Excuse me. On the one by one basis, but like for example the punch down tool for Bics is about $100. Then the punch down tool for 110 is another $100. Maybe a crimper for this, and it's all those specialty tools usually run about $100 or so. Okay, I can hear on the chat line, able to hear. I'm looking at my indicators. The sound should come through. Sometimes I get paranoid because I forget to unmute, and I keep talking, and then I'll get the chat lines shouting at me, "Yeah, we can't hear." No, I guess the sound is coming through. All right, so, well, I'm pretty sure. All right, so that's as far as the logistics for this week and as far as the lab. And of course, remember to bring safety glasses. We need to have you to have safety glasses in this lab during the hands-on activities. All right, so as soon as somebody has some tools in there, then yeah, if everybody's working on the computers and there's no work being done, yes, you don't need safety glasses to work on the PC or a tablet or a cell phone. But as soon as we do hands-on activities or is there any single person doing any hands-on activities in that room, then we need safety glasses. That's just the rules that we need to follow. All right. So let's see here. Okay. Today we're going to talk about something that's called network types. This type of business that we're dealing with here, it's a service type of business. Basically, it divides into two things. Service calls. A service call is trip that you make to the client's site that involves repairing something when something went wrong. Okay. The other part of the business is new installations. So that's the basic thing, and anything else, professional consultations and whatnot. That's excuse me. That's just like everywhere else. But basically, it's new installations or service calls when something went wrong, something needs to be repaired or fixed. Okay. All right. So when you're dealing with that, it's a good idea, extremely good. It's actually crucial thing for you to know what you're dealing with. You need to know when you're dealing with networks, at least you need to know what you're dealing with as far as what types of networks exist. So if somebody is talking to you and giving you specific instructions about anything that has to do with this business, so you can properly receive the instructions, so you can do your job as well properly. All right. So this week we're going to talk about the networks types, and the other part of of this week's lecture, which is going to be the second hour you're going to receive at another time during this week, is going to be the networks topology. So that has to do with the way the networks are, or anything that can be considered as a network. Is it a computer network, Ethernet network, or any kind of infrastructure, how it is physically arranged, physically and or logically. All right, but today we're going to talk about the networks types. So let's just start that. I'm going to start the show. All right. Computer networks, introduction to network types. All right. And of course, here is a funny picture because, I'm a funny guy. All right. There you go. Get rid of the definitions first. Let's cover that. Definition. Computer network is, it's a group of computer systems. When we're talking about the Ethernet data infrastructures, so you're going to be dealing with some sort of a computer or computer-like equipment. So we're talking about a group of computer systems and other computing hardware devices that are linked together through communications channels. And as far as we remember, the communications channels would be mostly we're dealing with copper, fiber, or air. Copper is the electrical wiring. Fiber would be fiber optics, which we will talk about later on during this semester, and air, which would be radio communications. So sometimes you are just not able to run a wire from one building to another, and you're just going to have to deal with utilizing antennas and associated equipment. All right, so that are linked together. Okay, so a group of computer systems and other computing hardware devices that are linked together through communications channels to facilitate communication and resource sharing among wide range of users. Networks are commonly categorized based on their characteristics. Now, network types we're going to cover in this class. We're going to cover LAN, which stands for Local Area Network, WAN, Wide Area Network, then Wireless Local Area Network, Metropolitan Area Network, Storage or System Area Network, or Server, or so that S can mean a lot, but it's basically, has to do with some sort of a common area that either files are being stored and you need to have access. So that would be like a centralized type of a network, and sometimes it's called storage area network, system area network, server area network, or small area network. All right. Then we will touch upon virtual private network, which is known as VPN. Over the last few years, this thing is becoming more and more, this concept is becoming more and more popular. All right, now I'm just going to throw in a picture of piece of equipment that I have installed. I think this one was somewhere around Niagara region, from one of the retail stores. You could see some of those acronyms here, like for example, the acronym OK stands for OK. Well, if the light is on, that means that something is okay. All right. Now, this gateway, which is the gateway to the network, is we can see that there's a few elements here that are associated with this particular piece of equipment. Like, for example, this gateway is connected to the local area network. So here is LAN, all right? Forget that FE thing. Just look at the LAN here. So looks like there are two ports at the back somewhere connected to local area network, and two LAN ports from this equipment are being utilized that are connected to the internal equipment that serves the network. Then what else can we see? We can actually see something called a WAN. All right, so that wide area network, that means the system is the system has found internet. If that light doesn't come on, then then maybe there's some issues with programming, because those devices usually on our level of service, they would be shipped to us already programmed by whatever company is providing the IT services. If you want to participate in programming these devices, then there is a whole bunch of courses that our college also offers that has to do with the IT services, right? Information technology. So, but as far as the network cabling course, or the network infrastructures, as I think it should be called, this is not what we're dealing with. We might have to do some programming with the assistance of level 2 support. Level 2 is the people who actually know the inside of this particular network, the particular setup of this network, whatever you're dealing with. They know all the passwords, all the structures, and all the way that has been set up and all that stuff. Then with some of the support, you might have to get your laptop and plug into the gateway, and with the instructions of the level 2 support, you might have to do some things to it in order to get this thing online, or do some changes. So usually when you plug this thing in, you're looking for brand new installation, or sometimes it's a service call that the gateway has to be replaced because something went wrong with it. And it's a common type of a service call. Usually in retail, if it's in retail, then it's almost like an emergency kind of a service call, because the whole store during the hours of operations can't operate. maybe some of them, when they have the backup systems, they will be operating on, if you could say that, slower RPMs. All right? But it's when there's a service call like that, usually it's a last minute call, and can you do it? Can you go and do it now? So once you replace the gateway in an existing system, you're going to be looking for some lights here. First, of course, you're going to have that OK light. Whatever that means, it means OK. And you're going to see those lights flashing in a different kind of sequence from one time to another. And it's going to take about a minute or so for this thing to boot up, to start it up. For startup. Now, then you're going to be looking for, these will probably come on right away first. So you just know that this gateway is connected to the rest of the equipment in the local area network. And then you're going to be looking for this light and that light. All right. So this one here, you're just going to look and look and look, and hopefully it's going to come on. Boom, it came on. Good. All right. So that means this thing here has found internet. All right. Then you're looking for that light, VPN, virtual private network. And it takes sometimes it takes some time, because, it has to go through all kinds of routines, logging in to the virtual private network. And then hopefully, boom, it came on. It's nice, solid. That means that this piece of equipment has found internet, and it's logged in to the virtual private network that is associated with this, maybe the chain of the stores, or it's found it's corporate. It's logged into the corporate network that is dedicated just for that business, which means this store can see other stores, or if it's set up that way, or more important, this store can communicate with the central node somewhere, wherever it is in the world, to report the transactions and all that stuff. All right, so that's in a nutshell here. And let's just take a look at some of the what is the first thing. All right, local area network. What is it? What is it? Just gonna look at my timing. We're doing good. Local area network. Local area network connects group of computers or other computing devices in close proximity within the same facility. It could be a building or a group of buildings. The purpose, again, sharing resources and services such as files, printers, applications, email, or internet access. That's sort of like a visual of what a local area network is. Notice that we're going to talk about the topology later, but the topology here is that everything home runs. All the jacks that are installed all over the place in the field, and the field means the rest of the building, goes to some kind of a central node. So there's a dry one-to-one connection between the jack and the port in the patch panel. That's a permanent link installed. And when you're doing the installations, sometimes you're going to have to provide the paperwork that has to do with the qualification of the link. So you will use something that's called a qualifier, a tester. And in that qualifier tester, you're going to save all the tests, cable test results, and you're going to just provide all the file with all the all the test results for every single particular link that is installed. Sometimes you're going to be asked, it's going to be in the contract, to provide not only qualification, but a certification. A certification is more rigorous testing, and of course they are going to be stored in the memory and presented usually in a PDF form. Dry links to patch panels, and those patch panels, every single port is patched using patch cord or patch cable, or connecting cable, to wherever it has to go. Usually on one-to-one, those patch panel ports are being plugged into something that's called a switch, or a group of switches, because if the switch doesn't have enough ports to accommodate all the connections, then we need to have more switches cascaded together. So every single jack in the field, which means the rest of the building, home runs as a dedicated wire, a dedicated cable that goes into some sort of a central node or central frame or local area network room. So you're going to hear terminology such as LAN room. Where's the LAN room? Sometimes people call it communications room. Sometimes they call it communications closet, or some similar terms like that. But LAN room is probably the most used term these days. All right. So that's how things are being arranged. Local area network. Now. All right. So one network can consist of multiple LANs working together. There could be some sub-LANs, or there could be one main distribution frame, and there's an acronym for it, main distribution frame, MDF, main distribution frame, and that main distribution frame can be connected to multiple IDFs, IDF, intermediate distribution frame, which would be another room somewhere that maybe serves a smaller area that is a little bit further, and because those Ethernet cables can only be as long as 300 feet. They can be no longer than 300 feet. So sometimes you will need another room somewhere that can accommodate other devices that are within close vicinity of that, that end-to-end runs are not longer than 300 feet. And that little room will be connected to the one big room. And there could be many little rooms, all connected also to the main frame. So here's the main frame, MDF, main distribution frame, connected to multiple IDFs, which would be intermediate distribution frame. If you go to some of the large department stores, like huge ones, like for example, like don't want to advertise, but one that ends with the depot is just look around the walls. You're going to see big black boxes, size of a small fridge. And you're going to see big labels on them that you can see from far, and you're going to say IDF A or IDF B and so on. So there will be the intermediate distribution frames, and those are connected to the MDF. There's only one MDF because, nomen. Main distribution frame. There's only one main distribution frame. So. All the IDFs connect with the fiber, usually with the fiber optics. They're connected to the main distribution frames, and from the IDFs, or sometimes from MDF, you can also run Ethernet wires to PCs and whatnot that are close to that. There's no one that says that you can't connect copper wiring to some PC that is close to it. Right? So one network can consist of multiple LANs working together. So the division could be physical, or it could be logistic or logical. So, for example, you could have a LAN within a LAN. It could be in the same room. You could have a different server for accounting. You could have different server for production plant. You could have a different server for management offices. You could have also a different server for customer Wi-Fi access. Like, for example, in banks, you can see Wi-Fi in banks. Now, banks are very sensitive when it comes to security of the network. But the thing is that if it's a bank that you can have clients walk in, with the cash tellers and all that stuff, Then everybody wants to have Wi-Fi access for some reason. So, okay, give it to the people because people want it. So you're going to see Wi-Fi or the wireless access points somewhere in the ceiling. However, that wireless access point is going to be connected completely into a separate anything. It's not going to have any kind of connection to whatever the main LAN has to do with the bank. It's going to be just like a complete separate connection. So yes, you can have Wi-Fi access server within the same frame, but it will be now not connected to anything else, just for the clients to, because when the client is waiting in line, they really have to have their Wi-Fi access because they want to watch their YouTube videos. It's okay. That's how things are done. All right. LAN, connecting a group of computers in close proximity. So I'm just giving you some, I'm giving you different possibilities what you may encounter when it comes to seeing those. Excuse me, a sip of coffee so my throat doesn't get dry. Oh yeah, time check. We're doing well. We're doing good. All right. So another scenario that I want you to take a look at. Okay, so look at connects a group of computers in close proximity within the same facility, a building or a group of buildings, a group thereof. This is a picture just a snapshot that I took from Google Images or Google Maps. Now, I wanted to find a couple of buildings that we could use for our lesson purposes. Now, I don't know what these buildings are. I don't know where their purpose is. I don't even know who owns them. Nothing. But let's pretend, for the sake of this lecture, let's pretend that these two buildings belong to the same business. They're the same business. Well, this building will have a bunch of computers and all kinds of smart devices that connect to the network. And this building will have also a bunch of offices, computers, telephones, and whatnot. But see that, excuse me. If you can see, they're physically separated, but we need to make sure that they work as one. Now, this is a very small example of that. Usually when, quite often you're going to deal with like huge facilities that include many buildings. It could be a facility that covers the whole area, especially when you're dealing with bigger cities, Toronto, some main distribution hubs for parcel services and all that stuff. It's almost like a small town, right? But everything has to be working as one common LAN, right? For the convenience of conducting the business. So we need to make this building one, without building walls here. And this looks like some sort of a badly represented picture of a tree or something like that here. So just so you know. Now, we need to make it look, we need to make it work as one local area network. So we might have the MDF, the main distribution frame, somewhere in this building, or we may have the MDF somewhere in this building. Wherever it is, that one building is going to be the one with the demarcation point. Demarcation is the point of entry where all the communications is going to be physically connected. So it could be some telephone lines, could be some coaxial cables, could be some, well, not that much anymore, but telephone lines. Usually you're going to have, within the new business, you're going to have either a good fiber connection run into the demarcation point, or you're going to have some radio equipment that is going to have a wireless link with some sort of a tower that is being placed within the area here. And it's just like having wires, so wirelessly connected. All right, so let's say this building has the MDF here, and that's supposed to, MDF, main distribution frame, that is supposed to serve as the main LAN, local area network, room or node that everything home runs to. What can you do? Can you just run wires with copper wires if there are no longer than 300 feet? So you can run from here to just run individual wires to all the jacks, the data jacks or Ethernet jacks. And then what? You're going to dig a big trench or have big overhead wire trunk going that you're going to have those wires going to the other building. That's not what you're going to do. You're going to have to, probably the good idea is to have some sort of a IDF here, which is the secondary LAN room or intermediate distribution frame. So there are a couple ways we can do that, right? I just separate visually those two buildings. Now, we can dig a trench and run a fiber optic line here, or fiber optic cable that includes many fiber optic strands, 6 or 12, or more. So what we're going to have, I'm going to introduce you to something that is called media converter. What is a media converter? A media converter is a device that converts one form of signal into another. Remember when we were talking about a transducer? A transducer is a device such as, for example, the biggest example would be a microphone. It converts one form of energy into another. So microphone would be transducer that converts the energy of vibrating air into the energy of electrical signals. But we're not talking about that here. We're talking about media converter. So this one here, we're converting one form of signal to another form of signal. So what do we have here? In the main distribution frame, the MDF, we have electrical signals running through the Ethernet cables, let's say copper wiring. We could have all fiber wiring too. And yes, there are some buildings that just run, we call it the running fiber to the desktop or fiber to desktop. So instead of Ethernet cables, copper wiring, you're going to have fiber optics running to the jacks, and that's how the signal is getting through the LAN. It's the signal, the LAN type of a signal goes to the computers and whatnot. But let's say this is, in this case, let's say, for example, it's copper wiring, so Ethernet wiring. Now, between here and here, these two buildings, this communication closet or distribution frame is connected to another one that's somewhere in this building through the optical fiber. What is it that optical fiber utilizes for signal? Well, light pulses, not electrical pulses, not electrical signal, but light pulses. So we need some sort of a device that will convert all the electrical signals that go around here into the light signals that can be transmitted over the fiber optic line. So that's why we need something that's called a media converter. So somewhere at the top or at the bottom, usually at the top of the equipment rack, there's going to be something that's called a media converter. And the media converter will be connected to all the switches and all the LAN equipment on one side, and it will be connected to a transceiver or transmitter and receiver that will communicate using light pulses, and that device that translates one signal from one to another, it's called media converter. And it's a bidirectional device because the signals go back and forth either way. And on this side here, also, you're going to, when the fiber optic runs to the other building, the first thing is going to hit is, well, some sort of a receiving equipment that has to do with the optical fiber signals, light pulses. And then the next first thing that is going to hit, the next first thing is going to hit is going to be the media converter that's going to convert the light pulses into electrical signals. Okay. Now, sometimes the media converters are called media players, depending on the purpose. Like, for example, when you go to Tim Hortons or Burger King or McDonald's or any kind of fast food place, you're going to see overhead on top of, behind the counter, you're going to see something that's called the menu boards. These are the monitors that advertise the products, some prices and so on. Those are connected with Ethernet cables. And you can make some money doing service calls fixing those, because they do go broke. If I can say that, once in a while, right? That's something to service. There's something that is made, the more things you install, the more things are to break. Things need to be serviced all the time. So the device that converts the Ethernet signal into the video signal, it's called a media player. And in the earlier days, it would be an external device connected to basically a flat screen TV that would serve as a media player. So on one side, you get the Ethernet connection. On the other side, you get the video cabling that goes to the TV. Later on, they would have some sort of inserts or modules that would be plugged in to the flat screen TVs that are designed for that purpose. And now these days, you just have the equipment all just built in, so you're going to have an Ethernet jack. But inside that, it's a media player or media converter. So you can do it with fiber optics. You can also do a wireless link. So then, of course, you're going to have a media converter here and media converter here, but the media converters are not going to convert from the electrical signal to the light pulses. They're going to convert the electrical signal into the electromagnetic waves that antennas can communicate with. All right. So now, LAN cable structure example. Just so I can give you some heads up of what you can encounter when you go to work in the field. And what did I say here? Not all networks are up to the highest standards. Some service calls look like this. Well, here's some kind of a shelf that was built and mounted, but you're going to have all the elements that are there. What do you have? You have a switch here. This here is, some sort of a makeshift patch panel. On the other side of these jacks, there's wiring, so you can see a little bit of wiring going there. Those are the wires that go to the individual jacks in the field, on the desktops and the walls and the ceilings and whatnot. So this was a small network. 1, 2, 3, 4, 5, 6, 7. Only 7 links, 7 jacks. So it's a really small business. Maybe a car shop, maybe a tire changing shop, maybe an oil change shop, maybe some smaller retail business. Right? Then those are being patched to the switch, and the switch is being patched to a gateway, and the gateway is being patched to the modem, and the modem is connected to the outside world. All the elements are there. It's not the prettiest thing to service, but who cares? I mean, yes, we do care. But what I mean is, you're going to have a lot of those. And you know what? Sometimes that's what you make the most money on, is those little small service calls or installations. If I were doing a new installation like that, I would just make sure that there's an equipment rack mounted to the wall, and all the equipment is mounted properly to the equipment rack, and maybe the equipment rack could be closed to prevent it from dust and all the impurities that's in the air and so on. But sometimes you're going to walk into something that was previously done. Just a word of advice: treat every client as a king. You're going to win on that. You're going to walk into something like that, and you're going to treat your client with the most respect, as if you walked into something like this. You're also going to treat that client with the most respect. Money is money, business is business. Just get into a habit of good service ethics, or looking for the word. Good habits of good customer service skills. There we go. Right? So some of the service calls might look like this. Some of the service calls and installations might look like this. Now look at this here. This is a picture from the internet I got from some Google server or something. It's publicly available. Over here you have equipment racks with bunch of equipment. Now look at this here. How much wiring is going on in there? There's a lot of wiring going there. Can you see any of the wires? All you see is some kind of patch cords here, maybe a wire here and there. Maybe there's some wire management devices or wire management raceways here. And those orange ones, they look like fiber optics and some other colors. It looks like there's a lot of fiber optics and there's some copper going on as well. Well, a couple things that I need to, this is where's all the wiring going through? There's a wire tray, but there's hardly any wires here. Maybe there's a couple of fiber optics around there. By the way, those orange raceways there, orange tubes, these are also usually for fiber optics. You also can see something that's called like a power distribution devices here. This thing takes a lot of power to run, and it heats up, which means you need to have another great amount of power spent to cool down the room, because if you don't cool down the room, it heats up so fast, and you're talking like minutes, that it could be damaged beyond any warranty services. So there's a lot of power. Aside from the power and the air conditioning systems that need to actually run for this whole thing to operate, for this whole huge distribution frame to operate, you need connecting wires. Where are they? Well, I want you to know that something like that exists. Look at this floor. They look like tiles. All right. So this is what I was talking about. You can read that. Basically, it says needs a lot of power. And where is the wiring? Where's the wiring? All right. Look at the floor. Here is something that's called a raised floor. And it looks like this. Very expensive floor, but some of the huge companies can afford that. And they're tiles, they're floor tiles, quite rigid, quite tough floor tiles, and quite tough and rigid construction that supports that. And over here you have the freedom of running all the wires whichever way you want, well, according to some neatness rules. And whenever you're going to service that with a raised floor, you're going to ask the facility management or maybe custodial services or whoever is meeting you there, you're going to ask for those suction cups. They will know where those are because there are people coming in and out servicing wiring. They will know where these suction cups are. Otherwise, you can't lift those up. Can't lift those. Wide area network. WAN. Now, as I say, sometimes we're approaching the 10 to time, 10 to the hour. So if you have to go to participate in any other classrooms, if you're scheduled to go somewhere else, by all means log off and go. I'm going to continue with this, so maybe there are going to be a couple minutes I'm going to run overtime. Then you'll be able to catch that when I post it on YouTube, and it's going to be quite, I usually post it the same day. Right? So I'm going to continue that. And if you have to log out and go. Just make sure you catch the end of it later on. And you're welcome to stay. All right, so WAN, wide area network. WAN joins an unlimited number of smaller networks in a way that the devices of different networks can communicate with each other. So my PC that I'm working on, I want to find out about types of giraffes that live in Africa. Okay? I'm going to log on to Google well, I'm going to call up Google server on my browser, and already that network through wide area network, which is basically the internet, I'm connected to some sort of physical Google server that is the closest to where I am. And the keyword giraffes is going to be searched. And if that Google server doesn't have the information, which probably doesn't, it's going to search for servers that do have the information about giraffes, and it's going to display pictures of giraffes, or maybe some technical information about how they live, the habitat, whatever I need, or any other subject, right? So through wide area network, I'm connecting to some sort of other server that connects me to another server and connects me to another server. And the whole thing works as a huge spider network of things. Example of WAN, wide area network. And there is actually a port that is called WAN on the modem or a gateway. And that's basically the internet. Woo. All right, so an example of a home device, but similar things would be on the commercial devices. It's just maybe, this thing is at the back, the other could be at the front, on the side, or whatnot. Let's analyze a couple things here. You see here, 1, 2, 3, 4. You have 4 LAN ports, which means those LAN ports can go either directly to a PC, or they can go into a switch, which could have many connections, and that connection is going to be shared through the switch with other PCs. Right? So, but you can plug in 4, or can you? Right? Because this one here, it shows, maybe you can't read it, but I'm going to say it says LAN and /WAN, or LAN1/WAN. So this can be connected to another PC, or it can be connected to a modem that has that provides internet. And then if that's the case, then you're going to have 3 LAN ports to play with. If you are using this, because this box has more than one purpose. Sometimes you're going to have a dedicated modem and dedicated gateway, dedicated switch, and whatnot. This here is all in one. It's a consumer type of device. It can be used also to connect DSL. Because DSL port, and it looks like a telephone jack, because DSL, digital subscriber line, the signal, the DSL signal, runs through the telephone line. So you just plug into the telephone port, and if you have ordered that type of service, you're paying for that type of service, and you're on. So the telephone company is going to make sure that signal, the DSL signal, is superimposed onto your telephone line. So then you can plug that, and you have 4 ports to play with. Okay. Of course, the other ones are obvious, so we're not going to even talk about those. Okay. All right, let's go. Wireless area network. As the word suggests, wireless suggests that this type of LAN utilizes wireless network protocols to establish communication between devices. It is possible to have a complete, almost 100 wireless network in most residential systems. Well, let's say almost 100%, because if it's complete wireless, if you have home that you don't have any wired connections to your PCs, you're using all wireless, then that modem and the wireless access point, it still has to be wired to something, and then it uses the Bluetooth or Ethernet or the whatever protocols is using to connect to your the Wi-Fi connection to your PC or cell phone and so on. Or wireless can be part of bigger network. So the network can have bunch of wired connections. And on top of that, you can also have a wireless device. So you can either connect straight with the wire, or you can just walk in and start using your laptop or tablet or cell phone if you connect the wireless network there. And usually they look like this. Look for devices like this in our school. We have a lot of them mounted on the ceiling tiles, mounted on the walls, and whatnot. All right. Can you support wireless access points mounted? Can you spot? Yeah, can you spot them mounted in our school? Presently, well, it's 2025 right now. The wireless access points, popularly called as WAPs, at Venture College, we are using the Cisco ones, and they have status lights. So if you see something that is green, that means nothing is connected to it wirelessly. Usually, if you walk into a classroom that's empty class, you're going to see a green light on those. And if you are logged into the school's network, it's going to take maybe 20 seconds or something like that, and the light is going to turn blue because it's detected your device, cell phone, tablet, or whatnot. If the light is flashing, then it's going to turn blue, right, when it's connected. And if the light is flashing, that means it's either booting up or there's some kind of a communications error. Here's another example of having wireless network in the conference rooms, widely used. Is everything going to go wireless? No. MAN, Metropolitan Area Network. Same as LAN, but bigger. LAN services a building or group of buildings. MAN services a city. Usually, it's owned by cities, so that's why it's called metropolitan. It's larger than LAN, but smaller than WAN, of course, because WAN is the whole internet. Such as a city, so network of spanning it's metropolitan network spanning a physical area larger than LAN, smaller than WAN, such as a city. Okay. A MAN is typically owned and operated by a single entity, such as the government body or large corporation. References and whatnot. Like for example, all the traffic lights, they are connected to some sort of frame that controls the traffic lights. They're connected to the MAN, Metropolitan Area Network. I need to provide references that I used. SAN, System Area Network. Let's give you a scenario here. Let's say there's let's say it's a school board. School board will have a main building that all the management of the school board goes there and they do whatever they do to manage the whole school board. They have offices, they have PCs and whatnot. Also, in the main server somewhere there, usually in that school board, there's a big server that has all the data about the employees' information, their addresses, their names, the banking information, the payroll information and whatnot. The whole thing that's lives there. What if something happens? There's a flood or a fire or something, and the building is destroyed. Is all the data going to be destroyed? No, because they're going to have separate copies of that server placed, usually in different schools. And that server is going to be the storage area network that copies all the information. So that information in that main building, the main facility, is copied for security purposes 2, 3, 4, 5 different times. So if there's a big disaster, there's always a bigger chance that one of the buildings is going to survive. All right. So links high performance computers with high speed connections in a cluster configuration, also known as a cluster area network. This is just a little type of example of Okay, let me just, oh, no. So there will be client here, and the client could be a PC in somebody's office. I'm just going to call it client. And then this client can access specific information on, maybe it's a payroll, maybe it's an accountant that does the payroll for everybody, and they will need to access the employees' information. So they will not go on the internet, but they will connect to the storage area network. Here's one bit of a cluster. Here's another, that's the simplest way I can, there's another example I'm going to give you. Like, for example, storage area network or system area network for the consumer, in a consumer type of world, right? Now, let's see an example here. Actually, here, before that, the system area network has direct accessibility to service or servers, indirect or conditional accessibility to the end clients. So if I work in the accounting department, I might have some rights to access certain type of information about the employees, but I might not have access to some other type of information about, maybe I don't want, if I'm an accountant just doing the payroll, I don't need people's medical information if I don't need to have that, right? So the access could be managed to storage area networks. End client might access system area network data based on the conditions, and usually based on what job they do. Right? Now, another example of that is, let's say, for example, here, local television service provider. Okay. On-demand, video on-demand service, right? And I'm still waiting for the royalties because somebody stole my face. Wink, wink. Now here's the true face. Better looking, right? Okay. Now, let's see how this thing works. Movies on demand, shows on demand. It all has to live somewhere, has to be stored somewhere on the storage area networks. Let's say here is a happy family gathered around a television set. Right? How is it that they can, let's say they want to watch some sort of a show, their favorite show. Their television set is connected to what the companies will sell you, they like to call it a TV box, which is really a media converter. Converts one type of signal to another. And it could have a modem in it, or that thing can be connected to a modem. And the modem is connected to the cloud. Okay, let's see what's on the other side of the cloud. There is the cloud here. Now that goes to some kind of a routing system of a local television provider, big building maybe. And that goes into something that's called a media retrieval rack. Or it could be called something else, but it's in that type of, similar to that. That's the back of it. And this will be the front of it. And these are pictures I took, so I don't have to provide references. So if you magnify that, this particular one has a lot of SCSI drives, a lot of hard drives. Here, see all those hard drives. This was a few years ago, and this equipment rack connection would have 230 hard drives. Each storage drive would be 1.8 terabytes, full of movies, shows, and other things. So conditional access, well, based on the payment that the client gets to the, $5, $6, $7, $10, whatever the movie you want to watch. They might have different prices. That goes with the local television provider. It goes with the bigger show content providers, and I don't want to mention the names, but some come to my mind, and yours probably as well. It works in the same way. That content has to be stored on some kind of a hard drive somewhere. All right. So that's where the storage area network comes in. and you're going to be given a password and whatnot, so you can access certain type of content based on certain type of conditions. Virtual private network. VPN, a secure, virtually created within the internet, a tunnel between two or more devices. VPNs are used to provide private web traffic. Otherwise, if we didn't have the internet structure spanning over the whole earth, we would need to hardwire connections between buildings. And if the building is close to the other building, well, it could be costly, but it's doable. But if the building is in another country, then you know what? You're out of luck. You can't do that. Now we can, because we do have that one thing that connects us all is the internet. And if you get a virtual, imaginary, but real channel that no one can get through, no one can penetrate, technically, but the other side of technically, anything can be penetrated. But it's quite difficult. So you can just say that's unpenetrable type of a connection, utilizing the internet bandwidth, which means like part of the internet is reserved for just my company and all the buildings that are associated. So I could be a huge corporation owner, and I could have mine building right here in my city, but I could have different office buildings all over the world. And if I purchase from a VPN provider, which would cost me some money, I could purchase a VPN service, virtual private network service. Then if all the buildings are logged in to that VPN, then all the buildings, all the office buildings and plants or factories that belong to me are all over the world. If they logged in, it's just like they could work almost as one big local area network. So it's a secure tunnel between two or more devices. VPNs are used to protect private web traffic from snooping, interference, and censorship and whatnot. Large corporations use VPN technology to link facilities located in different geographical locations. Like, for example, all the Walmart stores, they are connected to Walmart VPN. So if you buy a piece of chewing gum or box of chewing gum in your local Walmart store, that transaction gets recorded and almost immediately is being sent to some kind of a storage area network that is connected also to VPN. That's how things work. And there are some examples on how VPN is being used. Okay, excuse me. I'm going to wait for the phone to stop ringing. Okay, it stopped. Okay, somebody picked it up. All right, so just some kind of different examples. Like, for example, the money machine, although transactions, they're connected to VPN. Services such as, for example, Netflix, YouTube, and all that can be connected to VPN. This is just a visual representation on the unpenetrable tunnel between two companies, two buildings. Now, let's see here. Another example. Let's say these are all this is the continents in the world. All right. Let's say you own a company that has facilities all over the world. You have a factory here, they all belong to the same business, same corporation. You can have them work as basically as a local area network by utilizing VPN connection. So the advantages of that, you can have instantaneous access to any kind of files, servers, information that can be exchanged between the PCs. Other thing is the telephony. It's called VoIP, which we will talk about. VoIP systems, voice over IP, which are the internet telephones. It used to be if that person sitting in that window right there wanted to call that person in Asia here, that's another window in the office there. They would have to pick up the phone, select a telephone line, dial a long distance number, being charged for a long distance, and talk to that person. Now with the VPN and the VoIP technology, you just dial extension of that person, and there's no long distance charges. There's no difference between dialing. If that person wants to dial some other person that sits in the other office in the same building, and if that person wants to dial that person that is on the other side of the world, just by dialing extension, thanks to that kind of technology, it's basically there's no difference between those two phone calls, and it's not even considered as selecting an outside line. It's just considering a dial somebody's extension. All right. Can we exist without internet? And I just have a little video that is kind of funny, but I'm not going to play that now. But you can play it later on once you download it. It's just basically a funny way of finishing up that lecture. But you got the content. And did we go over time a little bit? Well, we get a few minutes over time. But hopefully that's going to be useful for you when you go out there and face the real world, or so-called real world. All right. Thank you for your attention. And this was it for today.